So we're talking about linear models.
Oh, okay.
You guys are going to be able to determine equations with real life situations. We've talked about linear models already before, guys, okay? We truly have. All right? These linear models are the ones that have lines as equations. Y equals mx plus c. You guys remember that equation? Mm-hmm. This was what form? Y-intercept. Or instead of y, it was called slope-intercept, where the m represents your what? Your slope. What's another word for slope? Gradient. And where c represented your y what? Your y-intercept, the point where the graph crosses your y-axis. So basically, we're going to be looking at some examples today of real-life situations in which we can create linear equations that represent the situation that we're dealing with, okay? And then from there, we're going to be able to answer like future questions or other questions based off of, what might happen depending on this equation. So the easiest way to do that, because I pretty much have covered, what you need to know about this, and this is what we did back in geometry and trig not too long ago. So we're just going to go ahead and jump into an example, okay? So 1 mile is equivalent to 1.6 kilometers. What we're going to do, and this is just one example of how linear equations apply to real life situations when you're looking at conversions. We are going to draw a conversion graph of miles to kilometers. We're going to find the gradients of that line, so we're going to find the slope, and then we're going to write down an equation to model for k of x, where k of x is the distance in kilometers and x is the distance in miles. So we kind of apply what we talked about in the last lesson. X is considered your what? It's a variable, but what type of variable is it?
Like independent and dependent?
Exactly. It's which one is it? It's the independent variable, okay? It's the independent variable, also known as the input. And k of x represents the output, the dependent variable, also known as y. Remember, when it's in that form of k of x or f of x, that basically means y. So when we actually are going to graph this, what are we going to put along our x-axis? What thing is going to be on our x-axis?
The distance in miles.
The distance in miles. So whenever we're doing graphs, whether it is for our homework, a test, our IAs, we want to make sure whatever graphs we do, we label the x and y axis, okay? So the x-axis is going to be miles, and the vertical axis is going to be kilometers or kilometers. Or one, however you say it. And of course, whenever you are making a graph, you always want to make sure that when you do your scales for your x and y axis, that they're even, they're good representations of your data, okay? In this case, all we really know is that 1 mile is equivalent to 1.6 kilometers. So how do you want to, how do you want to label your x-axis and your y-axis? Do you want to do it by 1s, 5s, 10s, 20s? What do you want to do? 2s, 1s, 5s? Okay? I mean, honestly, any one is going to be acceptable. We are going to have to find the slope of that line based off of those points that we use. Okay? So I mean, what you want to do? Let's come to consistency as a group. All right, so we're going to go by 1s for the miles. Okay, so it's going to be 1, 2, 3, so on and so forth. Okay? Now, depending on what we get, the conversion from miles to kilometers, might affect how we label our y-axis, okay? So let's kind of just pick a few numbers. We already know that 1 mile is 1 kilometer, but 5 miles is how many kilometers? How do you figure that out? 5 times 1.6. Someone do 5 times 1.6 real quick?
8.
Is 8 even? Okay, so we know at 5 we should be at 8. Now somebody do 10 miles. 10 miles is how many kilometers?
That should be double.
It's 16. So if we're at 5, 8, and then 10, 16, and we only have 10 lines here, how should we do our Y scale?
Like fives.
Twos? Maybe twos, because there'll be like 2, 4, 6, 8, 10. And of course, whenever you're making a graph, you want to make sure that your scale and your graph is about 75% of your graph is being used. Okay? 75% or more. Okay? There's no need to have this super huge graph. We just got a little drawing to go with it. Okay? So let's figure out the rest of these points. Of course, we have 0 miles. When we're at 0 miles, how many kilometers is that? 0. We already know at 1 mile, we're at 1.6. 5 miles, we're at 8. And 10 miles, we're at 16. So let's figure out all the other points in between. Okay? Let's figure out all the other points in between. All right, so when the miles is 2, what's the kilometers? 3.2. Okay. And then when it's 3?
4.4.
All right, continue shining them out. 4.
6.4.
And I know 5, 6.
9.6.
11.2.
12.8. 14.4.
Where'd she go? 12.
So then we got 16. Okay, so we're basically looking at kind of like a line a little bit, maybe not exactly there because of course my scale is not like to the T. If I had like a more detailed graph, then it would be, okay? But now we're gonna find the gradient of that line, okay? You're going to find the slope. So the easiest way to find the slope is to do what? Rise over run, which means we need to pick 2 points. Hey, I already have 2 points written down here. Just simple. And they're nice and whole numbers, no decimals. Very nice. So we're going to do our y's. This is part B. Y's minus y, x minus x. And what is that? 8 over 5, or we can even say as the decimal. Or 1.6. Either one will be acceptable. Okay? Now, it says, hence, write down a model for K of X, where K of X is the distance in kilometers and X is the distance in miles. So basically, they want us to write a model, aka an equation, where instead of writing y, we're writing K of X, because that is our output. And then we have our slope times our independent variable. Well, our slope is 8 over 5, or 1.6x. And then C, where does this graph cross the y-axis?
0.
And 0. So I can put plus 0, I can leave it as it is, but there it is. There is my model to convert between miles to kilometers. Now, if I wanted to, I could ask you guys, okay, so now 1,000 miles is how many kilometers? What would you do? If I asked you 1,000 miles would be how many kilometers? You plug it in. 1,000 times 1.6 to get 1,600. That's how many kilometers is 1,000 miles. You plug in 1,000 for x, yeah, because that is our independent variable, and we're looking for our dependent. I could do the other way too. I could ask you, okay, well, 800 kilometers is how many miles? If I asked you in that case, you would plug in 800 here, and then you would solve for x by dividing, because x is the miles. That's what we're looking for. You see how you use the models to do like follow-up questions? Okay, let's look at the next one. In a chemistry experiment, a liquid is heated and the temperature at different times is recorded. The table of the results for one student is shown up here on the screen, but not on your paper, so you do have to write this down. Right. So for this one, we are going to graph this data. Now, this is always nice when the data is kind of given to us instead of us having to find it ourselves, because then we can kind of scale it accordingly. Okay? So let's graph this data. What's going to be on our horizontal axis, on our x-axis? Time in minutes, and then on our y-axis, the temperature. Okay, so we can go ahead and label that. like an extra week on my own. And how do you want to scale this? Okay, we have 2, 4, 6, and 9, right? Well, we want to make sure we use some space up here, so we can definitely go by ones. Okay. Each line represents 1. What about our y-axis? What do you want to go by? Want to go by 5s? What's our largest temperature value? 65? And so we go by 5, 10, 15, 20, 50. We won't have enough to get that 6 out. So let's go by 10s. So at least in this way, probably about a little over 6% we use on our graph. And let's plot our points. We have 230. I don't want to keep moving back and forth. It's 2 and 230.
440.
440.
650.
650.
965.
9 and 65, which is like halfway. We want to draw our line to connect them. And I'm not quite sure exactly where it's supposed to like cross through my y-axis, but I think it might be there. I know there's a way I can definitely figure it out. For sure. Alright, so we plot our points, connect them, and now let's answer part B. It says find a model for T of X, the temperature with respect to time for the data. So T of X is basically the temperature with respect to time, because that's your independent variable. And to write a model, an equation, we need a what? Whenever we write an equation, what do we need? We need the slope. So we need to pick 2 points to find our slope. What 2 points you want to use? 230? 650? Cool. And honestly, it really doesn't matter which 2 we use. I think 4th period I used the first and the last one, and I think we're still ending up with the same slope. So as long as we, whatever points we stick to them, we answer it, we'll be all right. So let's find the slope. That's going to be 50 minus 30, right? Over 6 minus 2. Okay. What's 50 minus 30? And 6 minus 2?
4.
My slope is
5.
5. So I have my slope for my equation. The only thing I'm missing now is what? The y-intercept. How do I find my y-intercept? Plug in to find my y-intercept, my C. What do I plug in for my y? 0? No, not 0. I mean, if I want to find my x-intercept, I could, but I don't even have a constant here. I'm trying to figure out where that line crosses my y-axis. How did we do that before? I could do that, yeah. So another way.
Eyeball.
Plug it in.
Plug in what?
Good question.
Plug in a point. Remember, you took a point, you plugged it in to find your y-intercept. Pick one of the points that were given to us. Which one?
650.
650. 6 and 50. So we're gonna plug in 6 for x and 50 for y, and we're gonna solve for c. What's 5 times 6?
30.
To solve for c, I need to
Minus 30 from 50.
minus 30 from 50. So where does it cross?
20.
At 20. So my equation, 5x plus 20, and actually not y equals, but remember it's a model, T of x. And there's the equation. Questions on that? No, part C says something. I don't want to keep flipping back and forth. What does part C say? Find the temperature after 8 minutes. So I'm trying to figure out what the temperature is after 8 minutes. What do you think I want to do with that 8? For X, that's T of 8. What is the temperature after 8 minutes? So 5 times 8 plus 20 equals 60. If you ever had to comment on that, or interpret that, or describe what that means, like that number, you would say something around the lines of, after 8 minutes, the temperature is 60 degrees Celsius. Something around those lines. Okay? What's C double I say? So how do we figure out the time?
Plug it in.
Be a little more specific.
Yeah.
Plug what in for what?
57 for X.
57 in for T of X. The Y, because this time we're looking for the minutes. Minutes represented X. So I'm trying to figure out after how many minutes is the temperature going to be 57 degrees? Well, how do I do that? Subtract 20. And then 5. So 37 divided by 5 is, so after about 7.4 minutes, my temperature is going to be at 57 degrees Celsius. Yes?
Why did you plug time in for Y when it's on the x-axis?
But here I didn't actually plug it in for Y, I plugged it in for the X value. Because remember, this is originally T of X. So I just replaced X with 8. I didn't replace the whole Y value, I just replaced the X.
I mean, for
this one?
yes.
Oh,
So
okay.
why did you plug in the time for Y instead of X?
Because the 57 represented the temperature, not the time.
Okay.
So that's why you plugged it in for this one.
So X represented
Time. Exactly. Question.